Today we have revolutionized aviation. We have developed the hybrid F-18E/F Super Hornet by incorporating a molten carbonate fuel cell into the actual plane. The fuel cell will power all the electronics, boost efficiency, and reduce all CO2 emissions into the atmosphere.
Shown here is an actual MCFC fuel cell. As you can see, it is too big to fit into a plane, which is why we have scaled our fuel cell down in order to power a single fighter jet. Because the jet turbines require actual fuel burning to power the turbine, we will use the fuel cell to power the massive computers on board the plane. By doing this, less fuel will be required to power the plane, leaving less of an environmental impact. Also, the air taken in by the jet's air intakes will provide the fuel, hydrogen, oxygen, and CO2 to continue the reaction.
Molten carbonate fuel cells operate like normal fuel cells in that they have a cathode reaction and anode reaction that together produce an electric current. In the beginning, for the cathode reaction, the oxygen reacts with the carbon dioxide to produce carbon trioxide. The carbon trioxide then flows through the electrolyte to the anode where it reacts with the hydrogen gas. It produces water vapor, carbon dioxide, and 2 electrons. The 2 electrons then flow from the anode back to the cathode, producing an electric current. The water vapor and heat escape out, while the carbon dioxide can be trapped and then recycled back into the beginning reaction. The benefit of using multi-carbonate fuel cells are that they can tolerate impurities in the hydrogen fuel and the oxygen fuel, unlike other fuel cells. Also, they use cheaper catalysts for the reactions, which means you don't have to spend a lot of money on precious metals such as platinum, which can increase prices by law. Those are the benefits of using a molten carbonate fuel cell.
To increase efficiency even more, the water vapor given off by the fuel cell can be trapped as well, and separated into hydrogen and oxygen gases to be used again in the beginning reaction by an electric current. Relying solely on a fossil-fueled turbine will waste a lot of the heat and other energy created into the atmosphere, whereas our hybrid plane will reuse its products to be reused in the reaction.
Most jet engines today are internal combustion engines, which means they take a fuel source combined with outside air to provide a combustion reaction, which in turn produces thrust when pushed through a turbine. They operate extremely efficient at high altitudes and high speeds, which is very suitable for fighters. Unfortunately, electric engines operate at just the opposite, at low altitude and low speed, which is not suitable for a fighter jet. When the molten carbonate fuel cell is combined with another power source, its efficiency can reach 90%, which is amazing. That means a lot less energy is being wasted, and a lot more is being put to use. Also, it would reduce emissions because there would be less fuel needed to power the jet engines in order to get lift, because most of the power from the jet engines would just be used for thrust and moving, whereas the fuel cell would deal with all the others. So you have a lot less emissions, more efficiency, and you'd be able to keep the same design because the engines would be the exact same. These combined create an ultimate plane that is the same size and shape, which makes it easy for the engineers to continue producing them.
Shown here is a diagram of a conventional jet turbine engine, with fuel combusting inside to drive the turbine. This is not incredibly efficient because the heat escapes the engine after going through the turbine only once. Our hybrid plane will minimize energy wasted by powering the massive computers inside the plane, leaving the jet engine with a lower power output required for a safe flight. By using these fuel cells in the hybrid planes, we can prevent jet fuel from further harming the atmosphere and ozone layer. We can also lower the total atmospheric pollution levels, and we can also lower greenhouse gas levels. By doing this, not only do we help the atmosphere, but we conserve fossil fuels for future generations. Finally, by using MCFC fuel cells in hybrid fighter jets, we will give ourselves and our future generations a better environment.